All right. Well, welcome everybody. I believe this is Tech Talk Tuesday episode number 13.
Right on.
And for those of you that may be joining us for the first time, although these are very familiar names on this list, all of the previous episodes are available on the Baseline Web Training YouTube channel. So if you go to YouTube and you search for Baseline Web Training, you'll find every episode that we've done previously. They're all 30 minutes long and you can use them as a resource. Today, we are going to be reviewing the AEMC 3-point ground testing equipment that is used to test grounding locations on two-wire control systems. Before we kick off, just like to make sure we introduce ourselves. I'm Andy Humphrey, RSM for the Northeast. We have Dan Conger, our National Training Manager, Chris Wright, our VP of Sales, and then you can say hello to Dan's backyard. That's the fourth camera here. And after a few short minutes, Dan is going to go outside and we're going to experiment with a live demonstration. So I think with that, Dan, I'll hand it over to you.
Awesome. 3-point grounding. What could go wrong if you didn't ground? I just love this picture because it's so dang dramatic. Shout out to DBC for sharing this photo with me. This was not a baseline controller, but it was a irrigation controller hanging on the wall, flew off the wall when the outside wire was struck by lightning. The surge carried all the way into the building. And since it wasn't grounded, it was ready to burn that building down. So I think this kind of speaks to the significance of proper grounding out in the field.
I think you need to really emphasize, Dan, that in the lower left-hand corner is the controller.
Explain this, because I didn't get it my first time either. And after it was explained to me, my jaw dropped open.
Yes.
So, because this is actually like 1 millisecond of a video recording, right? Saved as an image.
Yeah.
Isn't that
right.
the case?
So, just to the left of the chair is a controller that is in the process of leaving the wall.
It's mid-flight.
Yes. And there's the 5 scorch marks as it incinerated what was left of paint on the wall, sent it across the room until the conduit caught it and is probably going to keep it to the floor pretty closely. And that surged at 30,000 volts, just brought it right into the building. So I don't want to see that happen on anybody's controller. Certainly not on a baseline controller. So the grounding, the equipment to test for proper grounding on the controller or on the two-wire path is relatively straightforward. This is the AEMC 4630 tester. This is a device that we essentially sell through. We have a partner where you can buy it directly from AEMC. There are some others that are similar, but we're going to talk about this particular model. And this is what comes in the kit. So we've got the yellow tester with that nice big yellow test button on the lower right-hand corner of the box. And then there's a red terminal, a blue terminal, black terminal, which we won't be using, and the green terminal. The red's going to go to the red spool of wire. The blue is going to go to the blue spool of wire, and then the green is going to go to a green lead, which will connect onto my ground rod, my existing ground rod that I'm actually testing. And then I've got probes that I'm going to probe into the ground to measure the resistance between the ground point that's already set in the soil and then these various points along the way. And we're trying to get a low resistance along that grounding path.
And that tape measure comes with the kit as well, right?
It does, because I'm going to go out 10 times the length of the rod. So if I've got an 8-foot rod, I'm going to go out 80 feet. If I have a 10-foot rod, I'll go out 100 feet. And then I'm going to take incrementally measure that resistance at 72% of that distance, 62%, and 52% of that distance. I'll take those 3 readings. And that will tell me if I have low resistance between my ground rod. Because if I have ground resistance, high ground resistance, it's as if that ground point wasn't there. So this comes in a complete kit. What's nice is it also has a rechargeable battery in there, so it's completely portable. You may want to carry. It comes with a nylon carrying case. I keep mine in a bomb-proof Pelican case. So this is the hardware I'm going to use outside, And here's the process and what I'm going to be actually doing. So I'm going to set up my yellow tester where the 4630 is on the left. I'm going to disconnect my ground rod from my controller or from my 2-wire path. And then I'm going to connect my green lead onto the ground rod that's already set in the soil. I'll take my tape measure, run it out. It's a 100-foot tape measure. I'll run it out the distance, at least 10 times the length of my rod. And then I'm going to take the red, what I'm going to call the Z lead, and go out 10 times the length, and put that probe into the ground and clip that red lead onto it. Then that red lead's connected to the controller. The next step is then to go out 72% of that distance. So 58 feet, if it's an 8-foot rod, connect onto the second probe with the blue lead, probe it into the ground. So I've got 2 probes in the ground and then 1 connected to the ground, and then take a test reading. I'll record that number and then move on to the next one. Then I'll come back in to 62% and then lastly to 52%. So I'll take 3 readings, average them together, and whatever that reading is, that is the resistance between the ground point and the earth that's around it.
Good. So it's the average of those 3 blue probes in that diagram. You're going to take 3 readings and average the ohm readings that you get for your overall reading, which to qualify for our 10-year warranty, which we'll talk about in a minute, would be at least 25 ohms or less, and preferably would be 10 ohms or less.
Absolutely. Yeah, the bare bones minimum is the minimum or maximum. The most resistance we ever want to have is 25 ohms, but we recognize that when we have less than 10 ohms of resistance, it's easier for that surge to jump off the wire, and we're going to have less damage on the system. So we're always going to encourage 10 ohms or less, even though 25 ohms will meet our true specifications.
Awesome.
Okay, I think I'm ready to go outside. So I'm going to take a moment to walk out, and I'll pop on camera in just a moment.
Okay. Good. And Dan, while you're walking outside, I will go ahead and share my screen. We'll talk quickly about the 10-year warranty. So let me grab this real quick. All right. Should be seeing my screen at this point. So the 10-year warranty application form can be found on the Baseline website. It's located under the support tab and then the warranty information. When it comes time to fill out the form, you'll fill it out online here where it says complete the extended warranty application form. And this is an online form. Oops. And you'll simply fill in all the required fields. For a quick checklist, there's also a paper version that you can reference. It's a PDF, so you can use this paper version either in your office or in the field to fill out ahead of time, and then you can take this information and go ahead and enter it online. So I'm going to also, after Dan gets started, grab this link to the PDF and put it in the chat so you can each have a copy of the requirements for the 10-year warranty. And Chris, is there anything you want to mention about the 10-year warranty?
Well, other than that's one of the best warranties in the business, and it includes 10-year warranty on all 2-wire devices that are connected to the wire path and the controller itself. So that is a massive value add that any project can take advantage of. You just need to go through the process and fill out the application to make it legitimate. So we keep those on file internally in support. So when you have a issue on a project that you're working on, you can verify that that project has the warranty, and we can pull that file and verify the ground resistance testing measurements and results, and then take care of you through the RMA process if necessary.
Good. Dan, we're seeing you out there on site. You are on mute. Can you go ahead and just click the Zoom unmute button real quick? We didn't want any accidental wildlife interrupting our show. I'm going to spotlight you.
A bear, we want to hear it.
That's right. The pandas or elephants are coming through.
Okay, now we've got Dan on spotlight. Take it away, Dan.
Beautiful. Okay, I'm going to show you the gear that I have. So I'm going to tip my camera down so you can all see what I've got set up here. So you tip down, you'll see I've got my 4630 tester. I've got the green lead, the blue lead, and the red lead. I've got those connected up. I'll show you what those are going to connect into. I've got my spools of wire. So let's bring that up and show you what I'm going to do. So the first thing I'm going to do is connect my ground lead. So that's the green lead that's connected in, right? This is the other end of that green lead. What I'm going to do is go to my ground rod that's in the ground and clip it on. That's all I'm doing. I'm disconnecting it from the controller ground or from the 2-wire ground. So it's just the ground rod itself. Now, if I had multiple ground points, which is a kind of an advanced thing, I would need to test them all together. So I might connect on the wire, but I'm almost always going to just connect directly onto that. So I'm going to do that real quick before I forget. So I'm connecting onto my ground rod, which is off camera. Next thing I'm going to do is take my red. Oh, no, actually, I can't take my red lead. I have to measure. So I'm going to go out 10 times the length of my rod. So, Andy, what we said this is an 8-foot rod. So I'm going out
80 feet.
Simple.
Yep.
Pretty simple math. And I'm just going to lay my tape measure out and leave it in place. I've learned over the years to do it the smart way, and I put this 0 end back at the ground rod so I don't have to do it multiple times, right?
Yep.
Now I can set a probe. One probe comes with the kit. The red alligator clip is going to clip on. The other one's on the meter. So I'm going to take this out the full 100%. So I'm going to go out to the full length, 10 times the length of my rod, and then probe it in.
So the red is out 100%, and that again is 10 times the rod length. So you're out 80 feet.
There you go. Yep, excellent point, Chris, because if it was a 10-foot rod, it would be 100 feet. So, okay, now I've got my
question for you, Dan, real quick. When you're putting the green lead on the grounding rod, do you clamp it right to the rod, or can you clamp it to the clamp on the rod?
Ooh, interesting point. I would go directly to the rod. There's a couple of challenges here. So if you had a poor clamp, you'd be taking that in. If you want to measure that, generally you want to measure just the rod. Now, if you had a rod with a CAD weld or a pre-attached lead that's already on there, you can't. You're probably going to have to, and that may be buried. You may have to test directly on the lead. My preference is always to go directly to the rod and not at the clamp. I don't want to calculate in that clamp itself.
Okay. All right.
Okay. Carry on.
Second probe, blue lead. So this is my Y lead. So I did the Z, this is the Y, clip it on. Now I'm going to go out 72%. So Andy, what's my math on this one?
So it is 72% of your 80-foot distance. That is 57.6 feet.
Okay, good. Which is why I left my tape here. I don't have to remeasure it. So I've got 2 probes in the ground. One at 100%, one at 72%. The third is connected to my ground rod. I've got 3 points connected, 3-point grounding testing. It's time to actually run a test. So I'm going to come back around and let you see what I'm going to see. It's really simple. I'm going to press the yellow button and allow the reading to stabilize.
This is great. We can see it very clearly, or at least I can. Looks great.
51.1 ohms. Andy, would you make a note of that? Because we're going to need to reference that.
Got it.
Okay. That was our first reading. Now it's time to bring that lead back into 62%. So what's the next distance, Andy?
So 62% of your total distance of 80 feet will be 49.6 feet.
Okay. Got that probed in there. So now I've got my second reading. Going to come back to my meter. We'll tip it down so you can see it again. And press the yellow button, let it stabilize. .4 ohms. Okay, you got that on our...
I'm seeing that the measurements so far are well above the 25 ohm requirement. So we'll want to talk about that at some point before when you're done.
Absolutely, you're right. So far, it does not look good because we're going to average through these together, and they've got to be below 25. So 50 plus 50 plus 0, well, that's still above. It's going to be probably not going to make it. So let's do the third one, and then we'll take a look at it. So third reading coming in, Andy, so at 52%.
Yep, 52% of 80 feet is 41.6 feet.
Okay.
And Dan, you do make a good point. If this was a real world test and you received 50, these first two numbers, you would know right away it's not worth taking a third reading. You've got to improve your grounding right away.
Because one of the things I'm looking for is I don't want there to be any more than 3 to 5% variation between these samples. So I said 50 and 50 and 0. Well, that big of a difference, you got to throw the numbers out. Something's wrong. And maybe it's a soil condition, maybe it's a grounding condition, but something isn't going to work. So to Chris's point, we all know this is going to fail because we've had too high of readings. And I'm expecting this third reading to be quite high as well, or higher than it's supposed to be. So let's take a look. Okay. 50.0, dead even.
Okay.
So we've got 3 readings. And what's kind of interesting is the readings did get incrementally smaller as we came closer into the ground rod, right? Expected. They're within 3% of each other. That's good. So what are our 3 numbers? Take those 3 numbers and add them together.
Right. So we had 51.1, we had 50.4, and we had 50.0. Add them together and divide by 3. We are left with 50.5.
50.5. That fails. It fails the 25 ohm, and it certainly fails the 10 ohm. This does not make baseline specifications. Doesn't make ASIC specifications. It just fails. And honestly, the first time I saw that 50 ohms, we would have known this failed. We didn't have to go any further because that just immediately discounted it.
So what do you do?
Ooh, excellent. Real good question. What do we do? Well, the first thing I'm going to talk about is moisture content. This is an unirrigated portion of my yard. When I first probed this in last week, when we talked about this concept, I had to hammer it in, and I had a resistance of 200 and some odd ohms. I watered this over the week. If I'd apply some more water and let it spread a little more in my clay soil, I would probably get my resistance down to 10 or 20 ohms. So it's still relatively dry, but moisture content makes all the difference in the world. Now, I'm not suggesting that you overwater where your ground point is, but I am suggesting you put your ground rod or your plate in an irrigated area. So put it in a turf area, right? Well, that's going to be great. Or if this was an area where I had to put the ground point, I could put a rotor or a spray head and just always keep this area moist, and that would keep my resistance low, and that would be good. So that would be the first one I'd look at, is moisture content. If you're putting it in an irrigated area and you test it day 1, man, let's just wait and get some plant material growing and let the moisture content come up. The other one is rod length, right? So if I'm assuming it's an 8-foot rod, and we look at the end of this and we say, oh, somebody cut that rod. Well, if I tested it at an 8-foot and it turns out that they hit a rock at 4 foot and just cut it off, well, we have half the contact against this in the soil that we're expecting. That would fail. So a longer ground rod or the right length ground rod makes a big difference. The other one might be soil type, right? We might just have some really crappy soil. So what often happens is fine textured soil, silt and clay, really good contact with that rod. Rocky and gravelly soil, it's only contact, or even sandy soil for that matter, it's only touching at various points on the rod, and that's really hard to have low resistance in those soils. You might have to go to a plate with the set material. You may have to go as far as to set multiple ground points, and that gets more challenging when you have sandy soils.
Exactly. Very good.
Tell us about the ground rod you have at your house there. Is it an official length ground rod, or is it a demo ground rod?
It's a demo ground rod that packs in my travel kit. I took an 8-foot rod and I cut it into all these different sections. Turns out when I wanted to drive a rod right next to my walkway in a very trippable place, I wanted to drive an 8-foot rod and I didn't have any. So I drove 2 3-foot rods, and the resistance is still high, and connected them together. So I have 2 rods connected with the number 6, with some number 6 wire connecting them together. Still didn't have it. So yes, no, they are not official length. And when I travel and I do this out in the field, I do the same thing. I'll have a short travel rod that fits in my Pelican case.
Yep. And Dan,
so I'm confident that if I would have put an 8-foot, I would have had it here.
Yeah. So just as a reminder, in case anyone joined us halfway through, where on the 2-wire path are we taking these readings?
Oh, okay. So our specification is that we must have a grounding point every 600 feet along the 2-wire path, and on spurs and terminations and within the first 25 foot of the controller. So generally it's every 600 feet along the 2-wire path. I'm going to take this ground kit, disconnect the ground wire from the 2-wire path, test the rod with this ground kit, and then move the ground kit the next 600 feet. And what I really want to tell distributors or contractors, whoever might be doing this test process, is it's not difficult. It's what I just told you right now. You could once you do this one time, it's easy. It's actually the harder thing is moving it every 600 feet, because you got to move this whole kit down 3,000 feet of wire path. You need to test every single ground point.
Would you use
it's worth it.
Would you use the same equipment for testing the controller ground?
No, that's a different one. That's going to be a clamp on. It looks like an amp clamp. It's essentially a grounding clamp meter that you test, and that's when something is connected to the electrical grid. So we're going to have the outside power system and your ground point that they're testing. So it is 2 different pieces of equipment that you would use. One for the controller and one for the. So if you have conventional wire, all you need is that clamp on, because you have no 2-wire path. If you're using 2-wire, you need that clamp and this 3-point ground test, or somebody does.
We've got a comment that came in regarding the time it takes to do this. It's not a difficult process, but if you've got an extensive 2-wire path, it is going to take some time. So if the site or the specification is animal,
I know, we have real wildlife.
if the specification is for the 10-year warranty to be applied, then the contractor needs to make sure that they account for the time that it's going to take to do this process, and make sure that's included in the bid and the scope of work, so that they get paid for it.
Right. So, they should definitely get paid for it and include it in the scope of work if they're planning to do it. And if not, keep it as an add alternate, perhaps with a price if they wanted to go ahead and apply for that extended warranty and account for the time and perhaps the modifications that may be necessary in order to meet the specification.
Right.
So to that point, when we do testing, you often may find things, or you may find things that don't meet specifications, that are not properly done, right? So if I went to 1,200 feet and open a valve box and there's no ground rod, well, I can't test it, right? I got to move on to the next one. That point automatically fails, and until that's resolved, you're not eligible for an extended warranty, and your system is prone to damage. So things that there are things that should have been done, but we're just calling attention to them.
Yeah, because we've all either heard of the contractor or seen it ourselves, where they put in a rod that's been chopped because the earth was very hard, and somebody just did a valve box visual, said, "Yep, there's the rod, okay." And if they tested it with this, they would certainly call out that
this is
grounding.
You can't hide with the grounding tester. It'll call it out.
Right. Yeah. What about high lightning prone areas? Would the specification change, or is it still every 600 feet?
The specification does not change. The specification is 600 feet. However, we strongly recommend that you go as close as every 300 feet in lightning prone areas. So as you move to the southeast, we're always going to recommend that you go 300 feet. If you did 600, you still meet spec, but you're more likely to have damage to your system. So how often do you want to have your system offline? Probably a lot less, because the whole thing on these grounding points is we're trying to get a surge off that 2-wire path and return it back into the ground. And the sooner we can do that, the less items we're going to damage. And if you don't have these, it's just going to go down your wire path, destroy all your decoders and everything else that's connected to that wire path. Think about that first image I showed, right? That's potential.
Mm-hmm. Yeah, good.
Very good.
Let's see, Chris, what types of questions we have coming in? I haven't paid too close attention here.
Where can one acquire one of the grounding test kit units?
So we do have a part number for this particular model. So you could order it through Baseline. You could, if you're a distributor, you could order it with Baseline bucks. There's kind of a bonus there, or you could buy it directly through AEMC or Electrical Supply. We aren't trying to make any money off of it, but we want you to please do it. Right? It's not a money making item for us.
Okay, so we do have part numbers on it. Awesome.
Mm-hmm.
Very good. Well, great field demonstration this week.
Yeah. Good.
Bringing Tech Talk Tuesday to a new level. We'll have to figure out more ways to get you out in the field.
Perfect. Dig it.
Yeah.
What's on tap for next week?
Next week, we're talking about modern radio communications. We're going to look at Ethernet radio, and it's not your father's Buick, right? It's the next generation of radio.
Yeah, and I always like to mention that we've been using the word radio for forever in this industry, and I hear it even now when we say radio, people automatically associate radio with old technology. The radio is just simply a word for wireless communication. You know, your cell phone is a radio, a Wi-Fi device is a radio, our devices, which are Ethernet radio, and so radio is a broad term that represents a lot of different products. And so I always like to preface that just because we use radios does not mean we are using a radio from 1980, 1990, or 2000 with our products.
Right. Yep.
Right.
Yeah, very good. Okay,
Awesome.
well, I think we hit this one right on the time limit, unless there's no last minute questions here. Let's wrap this up.
Mr. Bannock wants to know what style of beer's on tap, but other than that,
in Michigan, we've got Bell's Oberon in season right now.
All right,
it's not even noon here in California.
Thank you so much for joining Tech Talk Tuesday. We appreciate your loyalty to our program, and we are committed to bringing you good content every week. So join us again next week, and we look forward to speaking with you again.
So long, everybody. Take care.
Right. Bye-bye.
See y'all. Bye now.